Right, you are free to have the first person give their first bit of information.
These students are developing their problem-solving skills by working in groups. Here, each group has been given a mathematical problem that has been broken down into a series of clues written on cards. Throughout the task, each group needs to identify the most useful clues, based on what they understand so far, in order to solve the problem.
The group work with the 3 circles was set up so they ended up needing to provide information. Each had information, but they had to share that information with others. And so it was externalising that problem-solving technique of asking questions, gaining some information, and then working together in terms of how those different pieces of information fitted together with one another.
Areas of the 3 circles are in the ratio 4 to 10 to 20.
The design consists of 3 circles. It's the most useful. We were told to draw a certain number of circles in a defined pattern, but we weren't given the pattern itself. We had to work out what the pattern was from cards, which we would selectively go through. So each person was given a certain number of cards, and then we went around the table several times, but each person had to give out a piece of information from one of their cards. And then eventually we ran out of cards, so at that point you then have to go through and solve it all, or as we did, solve it before you run out of cards.
Areas of the 3 circles are in the ratio 4, 9, 20.
In our group, somebody was reading out the card, and then the other 2 of us were looking back at all the other sort of information we already knew and thinking, what does this new piece of information tell us about all the original pieces of information we have, and can it give us anything which helps us find where anything goes or helps us. So that's the centre of the largest one.
Yep.
So do we not? We don't know where the centres of the 2 smallest ones are yet.
No. Because when we do the extension thing,
If we know this one, can we work out the area of this one and then...
Everybody had a bit of information that the others didn't have, so they definitely had to share information. So all were involved, and you could see as we were walking around the tables that all were participating in one form or another.
It's useful as it requires a lot of communication between each other, because if some person just forgets a piece of the information, then that might be a key piece of info which you just missed out. So the second smallest circle passes through the origin, right?
yes, so the middle circle passes through the origin.
Okay, so we know basically it's got to do something like
Yes.
that.
They had limited information to start off with, and they started building a picture based on each additional piece of information. So they were gradually getting to grips with different aspects of the overall problem.
I think once you started getting it down, it was easier to see how the previous bits of information you had could link to what you were trying to do, whereas when you're just getting the initial pieces of information, it's more difficult to see what you actually need to do with them and what they can tell you.
Like, writing it all down means you've got all the information here and you can keep going back, referring to it. And you're like, oh, wait a second, this links to that. So you can then go back, link it up, and then you've got even more information.
Each time it was like a process of going through, what do we know? So what have we got now? Is there anything else anyone else can add that they've maybe remembered that everyone else has forgotten that you might have missed?
So it was a piecemeal approach towards problem solving. Every new piece of information ended up getting them a little bit closer to the solution. And with problem solving, if you can bite off a small bit at a time, you get yourself closer to the actual final answer.
So this goes for the midpoint of the smallest, doesn't it? So like the midpoint of the middle circle goes for the midpoint of the smallest circle, doesn't it?
I don't think anybody was left out, but there were differences in levels of contribution. There was a good camaraderie in each of the groups as they were working through. They were working with each other incredibly efficiently.
So that's 6-0. Then the ratio is 2, so radius 2 passes through here as well.
Yep, and it contains that.
So that's done.
Yes, that's pretty much the pattern.
Yeah, that's done.
I think there was a sort of sense of achievement that you'd been able to piece everything together.
I thought the activity went extremely well. It was just seeing students enjoying maths together. I enjoyed the activity, actually. They were teaching each other as to how to solve these particular problems. They needed limited explanation, and it was a joy. It really was.